Hello students, this is your third video in relation to the chapter Matter in Our Surroundings. Now here we shall start our discussion with something called change of state. Now normally whenever we say that a state is changing, that means temperature and pressure both are responsible for changing the state of matter. Now when a solid is heated, it will change into liquid. Whereas when a liquid is heated, it will change into gas. On the other hand, when the opposite thing is done, that when a gas is being cooled, it will change to liquid, and when a liquid is cooled, it will change to solid. So basically, this is nothing but the interconversion of the states of matter. So heating and cooling are the two processes during which a particular substance will actually change its state from one form to another. Now, as and when we move across for this particular point, there are different scales of measuring the temperature. Now, we basically need two scales. One is degree Celsius, another is Kelvin. Now, remember the conversion factors, how to convert Celsius into Kelvin and Kelvin into Celsius. Now, remember 0 degree Celsius is equal to 273 Kelvin. 0 degree Celsius is equal to 273 Kelvin. So based upon that, if you want to convert degree Celsius into Kelvin, plus 273. And if you want to convert Kelvin to degree Celsius, minus 273. That should be the basic formula for conversion. Now, starting with change of state of matter, if you just see here, when ice is changing to water, the particles are very close together and cannot move about in case of ice. But when you supply heat, very slowly the kinetic energy within them will increase and they will change into something called as water. So the particles will move faster. Similarly, when this water is being heated more, that is, we go for the process of boiling, the particles will gain more kinetic energy, intermolecular force of attraction will be more or less, and the space will keep on increasing. Thus, it will get converted into something called as steam. Now here we introduce you to a term called as melting or fusion. So basically it is a process by which a solid is being converted into the liquid state by heating. Now normally the temperature at which a solid is going to melt, that is called its melting point. And the melting point will determine how strong the force of attraction between the particle is, how strong it is. Like a simple example is given, the melting point of ice is 0 degree Celsius or 273 Kelvin. Now during the change of state, we are supplying heat to break the force of attraction between the particles. So that particular heat is known as latent heat. The word latent means hidden. So latent heat of fusion is the amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point. So that is called latent heat of fusion. Now you just see what actually happens during melting. Suppose you are supplying heat, temperature of the substance will increase. Due to that particular temperature, kinetic energy of the molecules will increase further. So thus the particles will start to vibrate much more faster. This will decrease the force of attraction and the particles will leave their fixed position. They start to flow, solid starts to melt, and it gets converted into the liquid state. In a similar fashion, when we come down to a topic called boiling, otherwise called as vaporization, which is the process by which a liquid is converted to vapor state by heating at its boiling point. So remember, boiling is a bulk phenomenon. That means the complete molecules of the liquid will start to get converted into the vapor state. Now the temperature at which boiling is going to take place, that is known as your boiling point. And the boiling point of water is considered to be 100 degrees Celsius. Now just like melting has got latent heat of fusion, boiling will have latent heat of vaporization. Now what is that? It is the amount of heat energy required to change 1 kg of a liquid into gas at atmospheric pressure at its boiling point. Now, just like we have given you the flowchart for melting, this is the flowchart for boiling. Now, when you are heating a substance, temperature will increase, kinetic energy will increase, particle will start to vibrate with more speed, force of attraction will decrease more, particles will start to move much more faster. When you keep on increasing the temperature, they leave their place at the intermolecular space increases and the substance will get converted into the vapor state. Now, just opposite to that, we deal with something called as freezing. Freezing is the process by which a liquid will actually get changed into the solid form. Now, what happens? When you cool the liquid, temperature is decreasing. With decrease in temperature, kinetic energy will decrease. Thus, the particles will stop vibrating. Their speed has decreased. Now this will increase the force of attraction. Now when the force of attraction will increase, the particles will start moving slowly. Now as they start moving slowly, what will happen? Space is going to be reduced, force of attraction will increase, and the substance will freeze. Now the temperature at which freezing will take place, that is called as the freezing point of that particular substance. Finally, the last stage where the change of state might take place, it's about something called condensation, where the vapor form will change into liquid state. So condensation is the process by which gases will be converted into liquid by cooling at a particular temperature. Now normally when a gas or vapor is cooled by decreasing the temperature, kinetic energy of those particular molecules is decreased. And due to that, the particles will start to move slowly. Now, as you keep on decreasing the temperature further, attractive forces between them will increase and thus they will condense and changes into the liquid state. So, this is all about the different state changes that will occur from solid to liquid, liquid to gas, gas to liquid, and liquid to solid. Thank you.